Okay, what we're going to look at first here is the resolution of a vector into its horizontal and vertical components, okay? So if we draw a vector, any vector, let's draw a vector like this, we need to give it a direction. Vector has magnitude and direction, and we'll call this 53 degrees, and this 12.9. Then we can resolve this vector into its two components, okay? This one is going to be called its horizontal component, and this one is going to be called its vertical component. All right. So, using the rules that we learned today, we are going to do this side is 12.9 cosine 53. Why? Because if we bring this way, we're going to crush the 53, and this is 12.9 sine 53. Why? Because if we do this, we are going to stretch 53. Okay? So 12.9 times cosine 53 is 7.76, and 12.9 times sine 53 is 10.3. Okay? So what we've got is we either have this vector here, 12.9 53 degrees, or we have these two vectors, okay, 10.3 vertically and 7.76 horizontally. Okay, so this is identical to this. No, they're exactly the same. They're absolutely identical. Now, the reason we do this is if we want to add multiple vectors together, like this and this and this and that, if we find all the horizontal components and all the vertical components, and we add all the horizontal components together and all the vertical components together, if we add all those together, we will end up with one big horizontal and one big vertical, and then we can make the resolution from them, and this will be the answer, okay? Before we get there, let's look at what we do with two vectors. So I'm going to have a perfectly vertical vector of 9.4 and a perfectly horizontal vector of 11.3. How do we add these two vectors together? Well, because they're perpendicular, it's very, very simple. We do that one is 11.3. We add this one to the end of it, which is 9.4, and that means that is the sum of these two. Now, because this is a right angle triangle, this is so simple. All we need to do is find this angle and the size of this. Well, we can find the size of this using Pythagoras. So let me call this Z. Yeah, okay, what do you call it? Z. Z squared equals 9.4 squared plus 11.3 squared. So Z is going to be equal 9.4 squared plus 11.3 squared equals square root, answer equals. So Z is equal to 14.70 to four significant figures. So that's the size, but what about the direction? Every vector has to have two things, a size and a direction. So here we have, using the tan, sine, cosine, tan alpha is equal to 9.4 over 11.3. So alpha equals 9.4 divided by 11.3 equals shift tan, answer 39.8 degrees. Okay, so notice what we've done here so far. First, we took a vector that was an oblique vector, and we resolved it into its components. Then we took two components. Two components here. The first one is this one, and the second one is this one. This is a horizontal component, and this is a vertical component, and we added to make this vector, which is 14.70 in magnitude, and it's at an angle of 39.8 degrees to the horizontal axis. Okay, so that's the basic thing that I'm going to show in that video.